Hi students, in this video we're going to solve a problem about the Bernoulli equation. So in this problem we have a horizontal segment of pipe that tapers from a closed sectional area of 50.0 centimeters square to 0.50 centimeters square. The pressure at the larger end of the pipe is 1.20 times 10 to the 5th Pascal, and the speed of the fluid in that segment is 0.040 meters per second. The question here is what is the pressure, at the narrow end of the segment. So basically, we have a pipe with a conic shape, right? And then we have this area here that have 50 centimeters square. The pressure at this region is 1.20 times 10 to the 5th Pascal, and the velocity of the fluid in this part is 0.040 meters per second. Now, in the other side of the pi segment, we have an area of 0.500 centimeters square. We don't know the velocity of the fluid in that part, or the speed of the fluid in that part, and we don't know the pressure, of the fluid. So this is a problem where we're going to use the equation of Bernoulli. Super important here to say that this segment of pipe is just in horizontal position, so the height of the segment in this part is exactly the same as the height of the segment in this other part. So in the equation of Bernoulli, we say that the pressure of point 1 plus rho g h1, plus 1 over 2 rho the square of the velocity 1 is equal to the pressure in the second segment plus rho gh2, right? Plus 1 over 2 rho b square, b2 square. Of course, we have to know that h1 and h2 are the same because the height, is the same because it's a horizontal pipe. We're going to cancel these terms, right? So now we have that my equation is P1 plus 1 over 2 rho V1 squared is equal to P2 plus 1 over 2 rho V2 squared. Now, we don't know the velocity 2, we don't know P2. How can we find velocity 2? Using the continuity equation, because I know that A1 times B1 is equals to A2 times B2. So the area in the region 1 times the velocity of the fluid in the region 1 is equal to the area of the region 2 times the velocity of the fluid in the region 2. I know the area 2, I know the area 1, I know the velocity in 1, so I'm ready to find the velocity of the fluid in the region 2. So I'm going to say here that the area 1, that is 50.0 centimeters squared, times the velocity 1, that is 0.040 meters per second, is equal to the area 2, that in this case is 0.5000 centimeters squared, times the velocity 2. So velocity 2 would be equals to 50.0 centimeters squared times 0.040 meters per second divided by 0.500 centimeters square. We simplify the centimeters square here, so our output unit would be meters per second, and we get, that the velocity 2 is 4.0 meters per second. So we found the velocity 2, so we're now ready to find the pressure, at point 2 using the equation of Bernoulli. So I'm going to say if I know that P1 plus 1 over 2 rho B1 squared is equal to P2 plus 1 over 2 rho B2 squared. If I want to solve for P2, I will just subtract 1 over 2 rho B2 squared from both sides. So I get P1 plus 1 over 2 rho B1 squared minus 1 over 2 rho B2 squared. This is equal to the pressure 2. I will take now 1 over 2 rho as common factor. So I'm going to say that P1 plus 1 over 2 rho times B1 squared minus P2 squared is equal to the pressure at point 2. We know that this is water, so we're going to take the density of the water, that is 1,000 kilograms per cubic meter. So I'm going to say that my pressure P1, that we said there is 1.20 times 10 to the 5th Pascal, plus 1 over 2 times 1,000 kilograms per cubic meter, that is the density of the water, times V1 squared. We have to square the velocity in the section 1, that is 0.040 meters per second square, minus, then we're going to square the velocity 2, that we said that is 4.0 meters per second. All this is equal to P2. So I have this 1.20 times 10 to the 5th Pascal, right? And then 1 over 2 times 1,000 will be 500. So this is 500 kilogram per cubic meter. And the difference of the square of the velocities is going to be, in this case, equal to negative 15.99, so just almost 16, so then I can say 16.0 meters square per second square. And all this is equal to P2. So when you multiply this minus 16.0 times 500, you're going to get that P2 is equal 1.20 times 10 to the 5th is going to be 120,000 Pascal. I will write this better in this form. The pressure 1 minus, because you have a difference here, and this would be 8,000 Pascal. The product of 500 times 16 would be 8,000 Pascal, right? Remember that Pascal is Newton, so over square meter. Okay, so you do the transformation, you're going to find, that this product give you these newtons per square meter, the kilograms over cubic meter times meter squares per second square, that give you newtons over square meter, so give you Pascal. So you can say that P2 is equal to, in this case, 112,000 Pascal. There is the same in scientific notation, at 1.12 times 10 to the 5th Pascal. So what is going to be the pressure to? What is going to be the pressure here in this region of the pipe would be 1.12 times 10 to the 5th Pascal. So this is a problem where we use the Bernoulli equation to find the pressure, at a given point of a pipe. So I hope this problem or this example help you to understand better this topic. Thank you.